So guys, welcome to our channel once again. In today's video on our WAEC Physics Exam Revision Series, we have here these 10 WAEC repeated questions to answer on the topic electric field. So guys, this video will be about resistivity and conductivity. So in short, stay till the end of this video. Let's start with the first question here. It says, a given wire of resistance 10 ohm has a length of 5 meters and a cross-sectional area of 4 times 10 to the power of negative 3 meters square. Calculate the conductivity of the wire. So guys, in order to calculate the conductivity of this wire, we have to recall that conductivity is equal to 1 over resistivity. So in that case, if we can obtain the resistivity, then we can obtain the conductivity. Then, in order to obtain the resistivity, we are going to use the formula for resistivity, where we know that resistance R is equal to resistivity times the length over area. In that case, if we make the resistivity the subject of the equation here, we're going to have that resistivity is equal to resistance times area over length. So where the resistance here is 10 ohms, then times the area, which is 4 times 3 to the power of negative 3 meter, then all over the length, which is 5 meters. So guys, let's go ahead and calculate this. So we're going to have 8.0 to the power of 3 ohm meter. So that's the resistivity here. Now to calculate for the conductivity, we're going to have that conductivity is 1 over the resistivity. So that's 1 over 8.0 times 10 to the power of negative 3. So when we do this, we are going to have 1.25 times 10 to the power of 2 per ohm per meter. And that's it for this question, guys. Option D is the answer to this question. So let's go ahead and consider the next question. So that's question number 2 here. It says, a resistor with fixed resistance value is called A shunt, B standard resistor, C multiplier, D resistance box. So guys, the answer to this question obviously is option B here, and that's a standard resistor. So a standard resistor is a resistor with a fixed resistance value. So that's it for this question. Let's go ahead and consider the next question, guys. That's question number 3 here. It says, a wire of cross-sectional area 2 pi times 10 to the power of negative 8 and resistivity 1.1 times 10 to the power of negative 8 ohm meter has a resistance of 21 ohm. Calculate the length of the wire. Take pi to be 22 over 7. Alright, so guys, let's go ahead and solve this out together. So guys, in order to solve this, we are still going to make use of the equation resistance R is equal to resistivity times length over the area. So if we make length the subject of this equation, we're going to have that length here is equal to resistance R times area A over the resistivity. So guys, in order for us to calculate this, we are going to impute the value for each of these. Resistivity is given here, and the cross-sectional area as well is given. As well, the resistance is also given. So we are going to plug all these things in, and then we'll get the length of the wire, as simple as that. So resistance, which is 21 ohm, times the area, which is 2 pi times 10 to the power of negative 8. So pi is given as 22 over 7. Then this is over 1.1 times 10 to the power of negative 8. That's the resistivity. So here 10 to the power of negative 8 will actually cancel out 10 to the power of negative 8 here. So what we'll have left here is 21 times 2 pi over 1.1. But let's recall that pi is 22 over 7. So let's say 21 times 2 is actually 42. So we have 42 times 22 over 1.1 times 7. So since pi is 22 over 7, so if we go ahead and calculate this, we'll arrive at 220 meters, and that's option B here. So that's 120 meters wire. So that's the answer to this question. Let's go ahead and consider the next question, guys. So that's question number 4 here. It says a resistance wire of length 2 meters and of uniform cross-sectional area 5.0 times 10 to the power of negative 7 meters square has a resistance of 2.2 ohms. Calculate its resistivity. So guys, again, we are going to still employ our normal formula. Resistance is equal to rho L over A. That's resistivity times length over area. So here we are calculating for resistivity. So make resistivity the subject of this equation, which is resistance times area over the length. So we have the length here, which is 2 meters. We have the resistance, which is 2.2 ohm, and we have the uniform cross-sectional area, which is 5.0 times 10 to the power of negative 7. So already we have all our parameters. We're just going to plug it in here, and then we get the answer to the question. So resistance, which is 2.2 times area, which is 5.0 times 10 to the power of negative 7, all over the length, which is 2 meters. And then let's go ahead and calculate this and see what we'll have. So guys, the answer to this question is 5.5 times 10 to the power of negative 7 ohm meter. And that is for this question, option C. So let's go ahead and consider the next question, guys. So that's question number 5 here. It says a wire of length 100 cm and cross-sectional area 2.0 times 10 to the power of 3 cm squared has a resistance of 0.10 ohms. Calculate the electrical conductivity. So guys, actually conductivity is 1 over resistivity. So we are just simply going to calculate the resistivity, and then from there we can get the conductivity. So resistivity here, like we know, will be rho is equal to Ra over L. So let's take note of the units we have in the answer. We have the units in per ohm per cm here, which means we are going to solve with the cm given to us here, and we're not going to convert it in meters anyway. So we'll have resistance 0.10 ohm times the cross-sectional area, which is 2.0 times 10 to the power of 3 cm squared, then over the length, which is 100 cm. So let's go ahead and solve this to get the resistivity. So actually this cross-sectional area is 2 times 10 to the power of negative 3 cm squared. So not just 2 times 10 to the power of 3. This is 2 times 10 to the power of negative 3. So there's an error here. So here, if we calculate for this, we are going to have 2 times 10 to the power of negative 6 ohm cm. But then, in order for us to calculate the conductivity now, we'll just simply do 1 over this resistivity, and then we are going to have 5.0 times 10 to the power of 5, and that's it for this question, guys. So option B is the answer to this question. So let's go ahead and wipe this and then let's consider the next question. So that's question number 6 here. It says, the symbol illustrated above is that of a resistor A, whose resistance is light dependent, B, which emits light, C, which absorbs heat to function properly, and D, which absorb light. So guys, the answer to this question is option C here. The resistance actually illustrated here will absorb heat in order to function properly. So that's it for this question. Let's go ahead and consider the next question. So that's question number 7 here. It says, a wire of resistivity 4.4 times 10 to the power of negative 5 ohm cm has a cross-sectional area of 7.5 times 10 to the power of negative 4 cm squared. Calculate the length of this wire that will be required to make a 4.0 ohm resistor. So guys, it's just as simple as just getting the formula for resistance here and then making L the subject of the equation. So when we make L the subject of the equation, definitely we are going to have R times A all over rho. So when we do that, we are going to just plug in the values here. The resistance given here is 4.0, and then the cross-sectional area is 7.5 to the power of negative 4, and then we're going to divide this by the resistivity, which is 4.4 times 10 to the power of negative 5. So guys, let's go ahead and calculate this. So guys, we're going to have 68.18 cm, and that's option D here. So that's the answer to this question. So let's go ahead and consider the next question, guys. That's question number 8 here. It says, which of the following factors does not affect the electric resistance of a wire? We have A, mass, B, temperature, C, length, D, cross-sectional area. So guys, the answer to this question here is option A, that's mass. So temperature, length, and cross-sectional area factors that can affect the resistance of a wire, but guys, the mass of the wire is not a factor that affects the resistance of the wire, and as such, option A is the answer to this question. So that's it for that question. Let's go ahead and consider the next question, guys. So that's question number 9 here. It says, a wire of length 100 cm has a resistance of 10 ohms. If its cross-sectional area is 0.005 cm squared, determine its resistivity. So guys, resistivity is resistance times area over the length. So the resistance here is 10 ohms. Then we'll multiply this by the area, the cross-sectional area. That will give us 0.005 cm. Then over the length of the wire, so that's 100 cm. So when we calculate this, we're going to have 0.0005 ohm cm. So that's it for this question. Option A is the answer to this question. So let's go ahead and consider the next and last question, guys. So that's question number 10 here. It says, a wire 1.0 meters long and with cross-sectional area 2.0 times 10 to the power of negative 7 meters square has a resistance of 0.1 ohm. Calculate the electrical conductivity of the wire. So guys, we are looking for the conductivity. So let's recall that conductivity is 1 over resistivity. So where resistivity is resistance times area over the length. So guys, actually we can just simply say that conductivity is length over resistance times area, since it's the inverse of the order. So if resistivity is resistance times area over the length. Then conductivity is length over resistance times area. So the length of the wire here is given to be 1 meter. Then this will be divided by the resistance times the area. So the resistance is 0.1 ohm and the cross-sectional area is 2.0 times 10 to the power of negative 7. So let's go ahead and calculate this. And then that's 1.0 over 2 times 0.1. So that's 5.0 times 10 to the power of 7 per ohm per meter. So that is for this question. Option B is the answer to this question. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community where we'll post major updates on WAEC examination. So this will help you even as you prepare for your WAEC examination for the year. You can join this channel community by hitting the join button below and we'll see you right there. So thank you once again for watching this video and see you on the next one.